Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture together. And today I'm going to be introducing you to AWS Strands SDK agent. I have done many videos in the past on various agentic frameworks like Salesforce Agentforce, LangChain, LangGraph, Agent Core, AWS Bedrock. So you might be wondering what's the difference in this new Strands SDK agent. AWS introduced Strands SDK in 2025 and it gave flexibility in how you program the agents. Instead of completely giving the control to agents and letting them autonomously figure out through the instructions on how to get to an outcome using the LLM's React framework, now we want to give that power back to the developers who want in certain areas where you want absolutely no compromise in how agent reasons through a problem and you want to implement certain developer guardrails. You can do that now using the AWS Strands SDK agent. In this video, I'm going to be walking you through an example of a travel booking agent, how it works through the problem of booking a travel using the autonomous capabilities through an LLM reasoning, but also the developer maintained logic, developer enforced guardrails. So without any further delay, let's get right into it. In this video, I want to clearly help you understand the differences between an AWS Bedrock agent and Strands agent, and I'm going to help you understand that through an example of a travel booking agent. The first thing that this agent will do is find out the destination city weather. If the weather is good, then it's going to find out all the hotels that fit within my budget within that city. And once it does that, it's going to calculate the trip cost. All of this will be done by an agent autonomously. It's a simple example, and we will see how Bedrock agent does this versus how Strands agent will do this. I'm going to refresh your memory on how AWS Bedrock agents work. I have done many videos on this in the past, so feel free to watch those videos. But essentially, the first thing that you do when you define a Bedrock agent is define the purpose of the agent in natural language. Then you define the Bedrock agent action group, which is nothing but a collection of tools and knowledge bases that a Bedrock agent has access to. Tools are nothing but Lambda functions, and Bedrock agent action group contains the OpenAPI schema definitions of these tools, so it knows when and how to invoke these tools. Another very important thing when you do define the Bedrock agent action group is definition of the instructions. Instructions are very important because they let the agent know how to orchestrate the tools, how to take the output from one tool and feed it into another tool, how to sequence the tools. In AWS Strands, that developer maintains and orchestrates the agent and tools logic. But in AWS Bedrock agent, the instructions are used by the agent to manage the orchestration. That's very important to know, that the orchestration is managed completely by AWS Bedrock and developers cannot change it, and developers do not have access to how AWS will reason through a specific problem. You can help alleviate that by defining clear and explicit instructions. On the other hand, Strands SDK agents work quite differently. Here, the agent orchestration is maintained by the developer of the application. What you're looking at is, I have written a Python function where I have access to various tools and have containerized and deployed it on ECS Fargate. Now the developer maintains how the sequencing of the tools occur. You can have a hybrid approach where you define very clear and explicit natural language instructions for the agent to autonomously pick and choose and sequence through the tools. But as a developer, you can also introduce certain level of determinism on how output from one tool is used into another tool. So as a developer, you get better control, and I would always suggest use a hybrid approach when using the AWS Strands SDK, as you want the agent to autonomously think. That's the smart part. But areas where you want strict control, a certain level of determinism, that's where you use the developer code. So Strands SDK, in my opinion, is more flexible than Bedrock agents. And finally, before I show you the code, I want to help you understand the flow of a hybrid agent SDK Strands agent. So essentially, the user launches a query. I want to plan a trip from New York to Sydney. Now the agent orchestration logic kicks in. First, you have to decide which tool to use, what order, how to explain, and what are the different follow-ups that are needed. I have access as an agent. I have access to 3 different tools: get the weather, get the hotels, calculate the cost of the trip. Now, as a developer, you can introduce various guardrails or various deterministic logic things like check the weather sustainability, return suitable if the temperature is between 50 and 85 degrees centigrades, search for hotels. So if the hotel rating is greater than 4.0, then move on to the next point, which is calculate the trip cost. Again, you can do the same things in Bedrock agent, but you will have to define those in the Bedrock agent action group instructions as natural language. It may work or it may not work depending on how clearly you specify the instructions. But using Strands SDK, areas where you want no compromise, you implement that as a hard rule through the code. And finally, you have ability to track and trace how the agent orchestrated through the various reasoning capabilities you have defined. Again, I always encourage you to have a hybrid approach where you are allowing the agent to think autonomously, but areas where you want absolutely no compromise, you want to introduce developer guardrails. So now let's take a look at the code involved in this. So now you're looking at a very simple code that I've written in Python for a hybrid Strands agent. Essentially, as a hybrid agent, you get to implement both developer guardrails as well as agent autonomy. As you can see, I have 4 tools available for my agent. These are deployed as Lambda functions in my AWS account. I'm going to expand one tool so you can clearly understand how Strands agent works. So the first thing you will notice is in natural language, I have defined the purpose of the tool. So whenever the agent is trying to find a tool that helps defining the weather, it looks at the check weather suitability rules because it reads the English language definition and purpose of this tool, and it knows, aha, I need to go to this tool. But now once it's in this tool and the Lambda function returns the weather, now you need to check the suitability of the weather. Now there are 2 ways to do it. You can define in English language, hey, based on the weather that is returned by the Lambda function, can you check it fits between 50 degrees and 85 degrees Fahrenheit? That's one way to do it, but there is no guarantee that the agent will do the right mathematical operation. So as a developer, in areas where you want absolutely no compromise, you want to do that through the code as it's done on line 33 and 35. All other tools operate in a similar fashion. One more thing that I want to show is when you're defining the agent, let's quickly go to it. So when you're defining the agent, you specify the purpose of the agent in natural language, you define the instructions, and this is how the agent orchestrates using autonomy as well as determinism in the case of AWS Strands SDK. Finally, I want to show you this agent in action. I have deployed this agent as a ECS Fargate container. I'm going to invoke this agent. The query that I'm sending is, I want to travel from New York to Sydney. Let me click send. And the agent is now thinking and reasoning through the various tools that it has available, and it's hopefully going to give me an answer on how to plan this travel and potentially give me a trip cost as well if everything works. Okay, so the agent worked because it had 3 things. It had the instructions that were defined for the agent in natural language, the purpose and the definition of the various tools defined in the natural language, and the deterministic code that you wrote as a developer so that the agent, the Strands agent, was work autonomously as well as deterministically to get me the output. So as you can see, based on the information we've gathered, here is a summary of your potential trip. It says the weather looks suitable, which is perfect because we looped through the weather tool. Then it says, okay, I have found several hotels like Sydney Grand Hotel. It has found a couple of other hotels, 3 other hotels, and it has calculated the cost of the hotels, and finally it had calculated the cost of the trip as well. So total is 1040. So essentially, as an agent, you can see how Strands agents can be really powerful. I will end the video over here because hopefully now you clearly understand how the hybrid agent architecture works using Strands SDK, how you can use the LLM's React framework, which is the reasoning and acting framework, to maintain the agent autonomy using the natural language instructions and the natural language definition of the tools. And then also you saw how the code can enforce certain guardrails that you want as a developer, where you want absolutely no compromise. Hopefully you were able to also understand the difference between Bedrock agent and Strand agent. In the next video, I will talk about how the graph builder capabilities work within the Strands agent. Hopefully you found this content useful. If you did, please hit the subscribe and like button so that I can continue making such videos, and also let me know in the comment section what other kind of videos you would like to see. Goodbye for now.